All right, guys, go ahead and open up your book to page 605. It should be lesson 3, volume of spheres. This continues our geometry section, finding volume. First of all, we have a vocab word here. A sphere is a set of all points in space that are a given distance, known as the radius, from a given point, known as the center. So basically, that's a fancy way of saying a sphere is all of the points that are a given distance from the center of a round object. So think of like a basketball is a sphere because it's all of the three-dimensional points. So not just side to side and up and down, but all of the three-dimensional points that are the same distance from the center. Like a basketball or a volleyball, the outside of it is all the exact same distance from the center. So it says describe the shape of the cross section. So the cross section here would be a circle. Okay? And then it says, name this part of the sphere. So what is this part of the sphere right here? In red, that's the radius. Okay? It says, name 2 examples of a sphere. So what are 2 examples of a sphere? Well, like the moon is a sphere, so is a basketball. Okay, so basically just when you think of a round object, that's a sphere. Okay, the cross section here makes a circle. It says name this part of the sphere. The exact middle we just call the center. Okay. Now it says Brittany purchased a necklace that contained a round pearl with a diameter of 7.5 millimeters. What is the circumference of the largest circle around the outside of the pearl? Round to the nearest tenth. Well, here this is asking us for circumference. Do you remember your circumference formula? Oh, and you guys can't even see that. So, there we go. It says circumference. So do you remember your circumference formula? Well, write this down. Circumference equals diameter times pi. So here it gives us our diameter. So the first thing I do is I write down C for circumference equals, I write my formula, diameter times pi. Underneath, I plug in what I know. My diameter is 7.5. Pi is 3.14. So then all I have is left is multiplication. So I'm going to multiply with my work. So I'm going to take 7.5. Now I'm actually going to multiply with the pi button because that's what your book wants you to do on your assignments is use the pi button, not just 3.14. And then it says round to the nearest tenth. That's 1 spot behind the decimal. So the 6 tells the 5 to go up to a 6. So my answer is 23.6. And what are my units? They are millimeters. Now circumference is just a regular distance, so they're not squared or cubed, it's just a regular distance. And these should actually be squiggly equals because we are rounded. Alright, now let's turn the page and look more at spheres. So right here you have your formula for a sphere, okay, for the volume. 4/3 times pi times the radius cubed. Now remember order of operations. You have to do exponents before multiplying. So you always have to do r to the 3rd power before you actually end up multiplying. Okay? So, pretty basic formula. Really all you have to do is plug in the radius and plug in pi and then just multiply. Alright? So here we have this sphere. It goes only halfway across, so we know it's a radius. We plug in 6 for r. So we first have to do 6 to the 3rd power. That's 6 times 6 times 6 times 3.14 times 4/3. And you'll get a number close to that. It's round to the nearest tenth. We rounded, that's why we have the squiggly lines. Now let's take a look at how this works. So for A, now notice, is this a diameter or a radius? It's all the way across, so that's a diameter. We only want the radius, so what's half of 22? 11 centimeters. So when I write down my formula, I'm going to write V equals 4/3 times pi times radius to the 3rd power. Okay? Then I'm going to write volume equals 4/3 stays the same. For pi, I'm going to write down 3.14 times my radius, which is 11, to the third power. Now I can't do this all at once yet. I want to first do my 11 to the third power. So I do 11 to the third power, and I get 1331. So now I have 4/3 times 3.14 times the 1331. Now I have all that, and I'm going to multiply it all at once. So I have 4/3, 4 divided by 3 in parentheses, times, now I'm not going to use 3.14, I'm going to use the pi button, times 1331. I get an answer of 575 point, now it said round to the nearest tenth right there. So that's one spot behind. So the 7 tells the 2 to go up to a 3. Squiggly equals because we rounded. Now what's my units? Centimeters to the third power cubed, because volume is always cubed. Now pause the video and do B on your own, but keep in mind that's already a radius, so don't worry about the diameter. So pause the video, do your work for B here. Alrighty. Hopefully you have B done. Now number 2. It says a spherical stone in the courtyard of the National Museum of Costa Rica has a diameter of 8 feet. Okay, so that's my diameter. Find the volume of the spherical stone, round to the nearest tenth. So I'm underlining the important information there. So here, notice it plugged in a 4, not an 8. That's because this was the diameter. You really have to watch that closely, whether you're given diameter or radius, because it's going to be switched around on you. So we cut that in half, and it was a 4. That's how they worked that one out. Now, let's look at this one here that we're going to do. It says a dish contains a spherical scoop of vanilla ice cream, with a radius of 1.2 inches. What is the volume of the ice cream? So here it's basically the same idea, just in a word problem. We still write our formula first. Volume equals 4/3 times pi times radius cubed. Then I plug in what I know. I know 4/3 stays 1/3. I know pi is 3.14. I know my radius is 1.2 to the third power. Then I do my exponent first. My 4/3 stays the same, times 3.14, which stayed the same, times my 1.2 to the third power. So I do 1.2 to the third power. That's 1.728. Notice I haven't rounded that yet because I want to keep that as precise as possible. Now I take all those and multiply. So I take 4/3, 4 divided by 3 in parentheses, times, I'm going to use the pi button instead of 3.14, it's more accurate, times 1.728, and I get 7 point, now did it say where to round to? It did not say where to round to. So in this case, I'm going to round to the 10th because the closest digit I had was the 10th right there. So 7 point, and it's 2.3, so that 3 tells the 2 to stay the same. So it's 7.2 inches, and it's volume, so it's to the third power. Okay? Now here it says a volleyball has a diameter of 10 inches. A pump can inflate the ball at a rate of 325 cubic inches per minute. How long will it take to inflate the ball round to the nearest tenth? So here, they basically find the volume, and then they set up a proportion for, okay, this is how many cubic inches it can do in 1 minute. This is the actual cubic inches, so it's a proportion. We know those are linked. We know that's the cubic inches of the volleyball, so we cross multiply, divide by what's left to find x. Let's take a look here. It says a snowball has a diameter of 6 centimeters. How long would it take the snowball to melt if it melts at a rate of 1.8 cubic centimeters per minute, round to the nearest tenth? So this is my important information. So I'm going to show my work. Volume equals 4/3 times pi times radius cubed. So volume equals 4/3 times 3.14 times my radius isn't going to be 6. Notice it gave me a diameter, which is, so the radius of that would be 3 to the third power. So volume equals 4/3 times 3.14 times 3 to the third power. Well, that's 3 times 3 times 3, which is 27. So I multiply all that together, and I get 4 divided by 3 in parentheses, times, I'm going to use the pi button, times 27. I get a volume of 113, and it said round to the nearest tenth, so that's 0, but the 9 tells it to go up to a 1.1, and my units are centimeters to the third power. Well, we're not done. That's the volume of the snowball. So I need to set up a proportion. What are the two things connected? Well, I know that a snowball, how long would it take a snowball to melt? If it melts at a rate of 1.8 cubic centimeters per minute. So I have 1.8 over 1 minute, just like it has here, where the 325 was over 1 minute. And then these are centimeters cubed, so those go over here. I want to know how many minutes, x, it's going to take. So I cross multiply, divide by what's left. So I do 1 times 113.1 divided by 1.8. And I get an answer of 62.8. And I round to the nearest tenth. That 3 tells the 8 to stay the same. And what are my units? My unit there would be minutes. So it would take 62 minutes about, or 63 minutes for that to melt. All right? So make sure if it's a proportion problem like that, you remember how to do that. Okay, last example. It said, find the volume of the hemisphere. Well, a hemisphere is simply a half of a sphere. Okay, it's called a hemisphere. Like in social studies, you probably learn about the northern and southern hemispheres of Earth. Well, a hemisphere is just half of a sphere. Okay, and if you notice your formula, 4/3 times pi times radius cubed, that's all the same. Then we just multiply by a half, since it's only a half amount. Okay, so the formula stays the same. You just also multiply by a half, since it's only half of a sphere instead of a full sphere. So if we look here to find these hemispheres, we look at E. I'm going to show my work here right underneath. I first write down it says find E. So formula first, volume equals 1/2 times 4/3 times my radius, times pi times radius to the third power. I then plug in what I know underneath. V equals 1/2 times 4/3 times 3.14 times, now my radius to the third power, this gave me a diameter. You have to pay close attention to that. So I got to cut 2 in half, which is 1 to the third power. So I have volume equals 1/2 times 4/3 times 3.14 times, what's 1 to the third power? Well, 1 times 1 times 1 is simply 1. Now I can multiply all that together. So I have 1/2, 1/2, times 4/3, 4 divided by 3, times, I'm going to use the pi button, times 1. We get 2 point, now it says 0.9, but I'm going to round to the nearest tenth, so that becomes a 1 centimeters cubed. All right, so that's how you do a hemisphere. Alrighty, one thing I want to point out on your homework assignment, all of this on the first page is kind of just like we did. One thing I want to point out here on 10 and 11 on the second page is it is giving you the volume of the hemisphere. It wants you to find the radius. So you're given the volume, you need to find the radius. So you write down the problem, the formula, just like we did here, but instead of finding V, you're finding R. Okay? So think about how to do that, all right? Give that some thought. All right, come tomorrow with any questions you have.